We're going to look at another example of integration by parts. So here we have a problem, the integral of e to the x squared e to the x dx. I'm sorry, the integral of x squared times e to the x dx. Well, I'm going to start by doing integration by parts. So I'm going to let u equal x squared, dv equals e to the x dx. By the way, it's often a good idea to let x squared be my u, because when I do the du, the derivative, I'm taking the x squared and making it smaller. That's not always the case, but it's often the case. Anyway, when I do this integration by parts, I get my original integral is going to be equal to uv minus the integral of v du. Now, v is e to the x. Du, there's the 2 and the x and the dx. That was all part of my du. I broke it all up. I took the constant out of the integral, and I just moved things around. But those are all the pieces that comprise my du. And now I have, but I have a little problem here, because this integral x e to the x, that's not a straightforward integral. See, the whole idea of integration by parts is that I want to take this integral, which is not straightforward, and then break it up where it's uv minus a straightforward integral. This is not straightforward. So guess what I'm going to have to do? You guessed it. I'm going to have to do another whole integration by parts to solve the second integral. Well, I'm just putting that in this special box here. So this is that inner integral, the integral of x e to the x dx. So I'm letting u equal x, dv equal e to the x dx, du is equal to dx, v is equal to e to the x. And now this integral is going to be x e to the x minus the integral of e to the x dx. But this is a straightforward simple integral. This is just e to the x. So I'm doing x e to the x minus e to the x. I could have put a plus c at this point. I chose to put the plus c in later, but there is a plus c. Anyway, let's see what happens. I have to take this now and substitute it into here. So this was my original integral. I got the integral of x squared e to the x dx is equal to x squared e to the x minus 2 times this non-simple integral. But I'm taking this non-simple integral and putting it into this big parenthesis here, and now I'm putting in that plus c. Again, I could have written the plus c up here, but I got to put it in at some point. And that is the story. Now, if you want, you could leave it like this. You don't have to simplify further, because I had an integral, and now I have functions without an integral. I don't have to simplify anything further. As they say, if you leave it like this, you can get full credit. If you try to simplify it and make a mistake simplifying it, you can lose points. But if you wanted to simplify it, you could just do this, and to get rid of the parentheses. Now notice here, I have x squared e to the x minus 2x e to the x plus 2e to the x. And then I wrote plus c. But really, why is it plus c? It's really minus 2 times c. So it should be minus 2c. The reason is because when I take c is a random constant. If I multiply a random constant by negative 2, I just get a different random constant. That's why I'm writing plus c, just plain plus c. Even though, technically even though from here you see it would be minus 2c, but minus 2c is just another constant, so I'm just writing plus c. And that is the end of that.